Hello and welcome to this new exciting video of Prototype 3 Part 2. In this video we will be going over the performance improvement system about which I will just inform you and show you how it works. So first of all, we are here in my game and I will just build two swordsman taverns so we can recruit some forces, because the performance issue was with forces. So I will just recruit, let's say 10 of those, and you can see them spawning in. And early on, I will just pause the game quickly. The problem was that each individual unit or force searched for enemies in its radius. Each of those, even though they are really near together, and there should probably only be one search. And this is just what I did. I also changed the search system itself, because now it's just a collider, which you can see here, and it keeps track of all group members, of course, but the most important point of it keeps track of all enemy forces. Early on I had some physics.overlap sphere function in use, if someone knows what this is, but it's less performant, because basically I just put a collider above the object and then get all the things that collide with this collider, and I do this again and again instead of just having one collider that keeps track of everything in its collider. And now with the search group, they are no longer searching by themselves. They are just asking the search group, hey, are there enemies in this collider? And the search group answers, and then they know where to go. Of course, with search groups, now there's the challenge that, as you can see, we need the search group to adapt in radius and position, because, for example, if I just select some forces and move them away, you can see how the position adapts, how the scale adapts, and if they move too far away, then let's wait for it. Okay, a little bit further. Boom, they split it. So now they are two groups, and this is simply how it works. Also, if I move them back, then they merge again. I think it's very visual, but of course to program all the stuff was a little bit of work, I'd say, but it was definitely manageable, and it really improved performance. We will talk more about this later. Now I will just show you this system in more action. So we will just produce a lot more forces, and also the enemy, the enemy produces rams, so he will not be a difficult enemy. Let's wait for all the forces to spawn in. They are spawned in. Now I just select them, and I forgot someone here. We will move these forces somewhere here, at this point where my mouse cursor is now, and you can see how they split while moving. And I will just show you the different groups at the different time intervals. For example, currently 2 groups, which is not that bad. And in this case, it splits one more time, 3 groups, but that's all. 4 groups, but you can see how they adapt. Now 6 groups for a short time period, and of course now there's also the enemy groups, you can see here, but that's basically the system in action. I hope you can see these collider lines. They're not too big, but I hope you can see them. I think they are pretty obvious, and maybe if we go into wireframe, it's even more visual here. So that's the system. If you have any questions left, then tell me in the comments. So now, to finish this video up, let's have a talk about the performance. This is at least the 10th try, because I always talk too much about performance. It's not that interesting, in fact. It's just the new system just uses 0% of performance, according to profiler values. But it is important to note that I use a collider, which is in the profiler values, it is in the physics values, So basically it uses some performance, that's sure, but I can't say how much. And the logic thing, so not the on trigger enter, on trigger exit, etc. If you don't count that in, then it takes 0% in each frame. Of course, not really 0, but less than 0.00%, which is really nothing. Even if you have 10 groups or more. Of course, if you have, I'd say, 1,000 groups, I think it would go up to, I don't know, 0.1% or so. But yeah, I couldn't test that with 1,000 groups. And also, of course, this number differs from frame to frame. Sometimes it's more percent as 0. I think the maximum was, if you count it on the player loop, 2%. But yeah, that's still nearly nothing. Previously, I had up to 90% in just one method, which is really bad, or which was really bad, because now it's no longer that bad. Now it's really perfect. As you can see in the last video, you can have a lot of groups, a lot of forces, and it works fine. So yeah, that's all I have to say to the performance. If you want to have more information, I think I will put some Illustrative figures down in the comments, but yeah, these are not representative at all. So yeah, you don't have to look at them. But yeah, that's it with the video. I hope you enjoyed it, and yeah, I wish you an amazing day. Goodbye.